All right, let's take a look at an example of a paired t-test. So an assertiveness training course has just been added to the services offered by a counseling center. To measure its effectiveness, 10 students are given a test at the beginning of the course and then again at the end. A high score on the test implies high assertiveness. At the 5% significance level, do the data provide sufficient evidence to conclude that people are more assertive after taking the course? You may assume that the differences are normally distributed. So we're being asked to test the claim. People are more assertive after the course. Okay, so our null hypothesis here is that the difference between the before and after scores, so it would be mu d, is equal to 0. And then our alternative hypothesis, so I want to define this subtraction as being after minus the before. So that's how I'm going to do my subtraction. And since we're thinking that people are going to be more assertive after the course, this number should be bigger, if that's really true, than the before number. So I would say that mu d should be greater than 0. Okay. We do have paired data. This is a before and after, so that part's fine. Random sample I didn't see stated there. Our sample size, so our N is these 10 students. And then we're allowed to assume that we have normal differences. So I'll circle that. And then I need to get my standard deviation of the differences. So I'll need to go to the spreadsheet for that. But once I've done that, then what I'm going to do is a paired t-test. Okay, and so while I'm there, I'll get this standard deviation and the average of the differences. So let's switch over to that. Okay, so here's our spreadsheet for assertiveness, and I have before and after. So the first thing I need to do is get my differences column. So I'll put an equals in, I'll click on the after box, and then I'll put a minus sign and click on the before box, and I'll press enter. So there was a gain of 15 points in assertiveness there. Then I'm going to copy and paste that for all of my data. And then I need to find the standard deviation and that average. So my standard deviation is going to be equals STDEV, and then highlight your data. So I get about 6.26. And my mean, my D bar, is equals the average, and highlight my data. And I get 5.1 for my average. So I'm going to put those two numbers down on my paper, 6.26 for the standard deviation, 5.1 for D bar. And then I'm going to switch over to that Excel calculator sheet and get the rest of the numbers for this, as well as we'll come back and take a look at how to do this another way on here. So hang tight. Okay, so here's our Excel calculator page. You'll notice I chose t-test chapter 20. So I'm going to put the average of my differences column in, which is 5.1. And then the mean, so our null hypothesis was a 0. So I'll put a 0 in there. My standard deviation was 6.26. And my sample size was 10, which means my degrees of freedom should be 9 because that formula is n minus 1. So I get a test statistic of 2.576. Okay, and then my p-value, since I chose greater than as my alternative hypothesis, is 0.0149. Okay, so that is one way we can get our p-value and test statistic. Let's go back and look at another way. So we'll go back to our spreadsheet with our data. All right, so let me show you another way to get the p-value. So another way of doing this would be to do equals t.test. And we'll open a parentheses, and then it says array 1, comma, array 2, comma, tails, comma, type. So array 1 just means highlight one of these two before and after columns. So I'll highlight the after. I'll put a comma and then highlight the before. So the key here is you're not highlighting the differences column, just the two original columns. put a comma, and then remember that our alternative hypothesis was greater than 0. So that's a 1 tail. So I'll put a 1 and then another comma, and then I need to tell it that this is paired data. So I'll put another 1 in. And there's my p-value, 0.0149. So it's the same p-value we got before. So there's another way of doing it. And then let me show you one other way of doing this, and that would be to use the data analysis. So far, everything we've done in this class, we've used that regression choice. But just below the regression, there's a choice called t-test, paired to sample for means. So if I double click on that, it wants my first column of data. And by first, it would be the first thing I used in the subtraction. So I'm going to use the after column. And then I'll use the before column for this other one. And I'll say, OK. And let's look and see what we have here. So there's our degrees of freedom that we had looked at earlier. Here's my test statistic. So 2.576, the same thing we got. And then here's my p-value for a 1 tail, 0.0149. Okay, so this is another way of getting that information. So both of those numbers are there, and you could just write those down. All right, so I've shown you a couple different ways to get at this information. Let's go ahead and finish writing up this particular test. All right, so I've put down everything that we've gotten from our spreadsheet, and now we need to compare our p-value to our alpha. So they gave us a 5% alpha. Okay, and so my p is definitely smaller than my alpha. So let me fix the zoom here. There we go. So p is definitely smaller than alpha, so I do reject the null. So with p equal to 0.0149 at the 5% significance level, we do have sufficient evidence. People are more assertive after taking the course. All right, so there is an example of a paired t-test.